So have you done the question? So what is the question? V is equals to minus 5 x square plus 3y plus 15z cube. Okay. So what was the answer you got? E is equals to minus 15x square. Then that's it. What about y and what about z? 10x plus 3y plus 3 plus 45 z square. Okay. So can I write this in terms of I, j and k? Minus 10 I cap plus 3 j cap plus 45, this is 10x I cap and z square k cap. So anyone having any doubt in the finding this answer? dv by, so minus of it will come, no? 10x minus 3, so no, 10 xi cap minus 3 j cap minus 45 z square k cap. So formula is E is equals to minus dv by dr. Okay. So we'll go for the next topic. Write down the topic. Electric flux. The next topic is electric flux. Okay. So listen here. Flux is nothing but like something is flowing. The meaning of flux. Okay. When I talk about electric flux, the electric field lines are flowing. Okay. So electric flux is nothing but the total meaning of electric flux is electric field lines are flowing. So the meaning of flux is nothing but a flowing. So electric flux is nothing but electric field lines are flowing. Okay. Write down. The first point, electric flux basically, electric flux basically the amount of electric field, the amount of electric field I will repeat the sentence. Electric flux basically the amount of electric field crossing, electric field crossing the cross section area, crossing the cross section area. Crossing the cross section area. So electric flux is denoted by the letter phi. Then write on the subheading, electric flux depends on. Electric flux depends on. The first point, electric flux depends on. The first point is electric field. Electric field. Second point is area of cross section. The first one is electric field, second one is area of cross section, and third one is angle between electric field and area of cross section. Angle between electric field and area of cross section. Okay, these are the three important things for the electric flux, and the formula is phi is equals to E dot S. E dot S. S is nothing but the cross section area. So when we are using the dot product, what is the angle we will get, sin or cos? Cos. So it is phi is equals to Es cos theta. Formula is phi is equals to E dot S or else Es cos theta. So similar to the work done, like force into displacement. Okay. Okay. So this is for the uniform electric field. Write down. This formula is for uniform electric field. Write down the next subheading for non-uniform electric field. For non-uniform electric field. For non-uniform electric field. So for non-uniform electric field, the formula is like what we have learned about the uniform force and non-uniform force, like formula in work done. W is equals to F dot S or else Fs cos theta. If it is a non-uniform, it is nothing but integral of F dot ds. Right now, I will write here W is equals to F dot S. This is for uniform force. When we are talking about non-uniform force, W will be equals to integral of F dot ds. Similarly, here we have talked about the uniform field. Now, if we are talking about the non-uniform field, so phi will be equals to integral of E dot ds, or else I can say phi is equals to integral of E ds cos theta. This is the formula. Completed? Okay. So if any object is given, no, like if electric field is passing that object, for example, if I take the cube, so electric field lines are passing like this. So I can say that only this back side and the front side, the electric field lines are passing. The top side and bottom and this front and back side is not passing, no. Only left and right it is passing. When I talk about the remaining four sides, it is not passing. and whatever the electric field lines are going inside, no, that one I should take it as negative, and whatever coming out, no, that one is positive. Okay. So now the question is, write down, find out the value of electric flux linked with electric flux linked with a cube which is placed in uniform field, E naught I cap. Okay. So in this question they have not mentioned about the diagram, but they have given the value E naught I cap. This I cap denotes that it is passing in x axis. Okay, it is passing in x axis. So it is a uniform electric field. Okay. Now let me take, this is the cube. So it is passing in x axis, no? What is the field here? E naught. That's it. I have drawn the I cap and I have taken the field as E naught. Now whatever is going in, everything is coming out or not here? So what is the electric flux now? 0. That's it. So electric field, I mean, like, let me take a flux outside will be minus E naught, correct? No? If I consider the side of the cube as A, so what is the area of the cube? Area of the cube. A cube. What is the area of the square? Only one side it is passing, no? Should I consider area of the cube or area of the square? Why? And what about the second one? This also square and this also square. I told that, like, top and bottom, front and back, nothing is there. Only left and right. So if I consider the left side, it is square. Right side also, it's a square. So can I say minus E naught A square for the out? I mean, which is, this is in, no? Sorry, this is in, and out will be E naught A square. So the total net will be nothing but in plus out. So which is equals to 0. Take down. What about this, madam? Or the cube like this. See, just draw a square, another square, connect these two things. So we have talked about the uniform. Okay. Now we'll see a question in non-uniform field. Completed? Still drawing the diagram. Yes, sir. Write down the next question. Find out the value. Find out the value. Find out the value of electric flux. Find out the value of electric flux linked with a cube placed in non-uniform electric field E naught x I cap. Okay. So listen here. When I talk about the electric field which is going in, no, how much distance it has been travelled? L in x axis. So if I talk about here, E naught L I cap will come, no? Yes or no? When I talk about this one, like coming out, how much distance it has been travelled? L plus A. Correct or not? So it is varying or not? I am talking about the x direction, like in I cap, positive I cap, okay, positive x direction. If I talk about the length, no, the distance, this is L. So electric field lines which is going in, it has been travelled L distance, which is coming out, it has been travelled L plus A distance. Correct, no? Write down. Okay. Flux which is in will be equals to minus E naught. So what is the distance it has been travelled? L. Okay, E naught L. What is the area of this? A square into A square. I am talking about the electric field lines, how much it has been travelled and the area. So I got the formula, no? Like electric field into area is nothing but flux. Now which is coming out will be equals to minus, I mean it is plus, no? So it is E naught times L plus A. Correct? L plus A. What is the area? A square. Now what I can do is the net flux will be equals to in plus out. So how much it is in? Minus E naught L A square plus. So if I take this one like to the inside, no, what happens? E naught L A square plus E naught L, I mean E naught A cube will come, plus E naught L A square plus E naught A cube. So can I cancel these two things? Yes or no? I will expand this one. Listen, E naught L plus E naught A into A square. So if I take this A square inside, it will become E naught L A square, and if I take this A square inside, it will become E naught A cube. Any doubt here now? Now I will add everything. So this minus and this plus will get cancelled off, and the remaining will be E naught A cube. So this is my net flux in the non-uniform field. So the next question is yours. You need to answer this question. I will draw the diagram, try to analyze it and answer the question. Done? Okay. Let me consider it's a right angle prism, okay. So the electric flux are passing the back side of the prism, like which is coming in, okay, and it is coming outside this side. Now what is the net electric flux? If you say the answer, tell with the reason. What is that thing? 0. Why? Which is same? Rectangle, rectangle. Same. Can you give this exam pads, please? See, I have taken the base and this is the right angle. Now it is slanting like this. This is the thing, okay. This is the passing in. Electric flux are passing inside. Now this side it is slanting like this now. It is slanting and is connected to the other side. Okay. So now what is the electric field? I mean electric flux. Now getting the point. Getting the diagram. Back side will be, it is like a rectangle or square, whatever it is. Front it will be like a slanting. Not getting. See, one more exam pad you gave, no? I can't handle this. Try to keep this as a slanting. Leave it, leave it. So this is the diagram. Okay. Now electric field lines are passing back side, which is going in, and this side it is coming out. So now I need to find what is the electric flux. So is this slanting or not, this one, the right side? I mean no, for me it's left side, no? It is slanting, and for this it is like a square. Now whatever it is going in will come out or not? think about that. What is the electric flux? Whatever the answer you said, it is correct, but what is the reason? All sides same. Arey, wait, I didn't complete that. Will it stand? Keep it. This side, opposite side, opposite side. Okay. So now you understood the diagram, no? Now whatever the field lines are going in, everything will come out, no, this side. So if I talk about this top also, the field lines will come in this tops, no, whether it can be whatever area, but whatever field lines are going inside in the right hand side for me will come to the left hand side of mine, no? Yes or no? So electric flux will be 0 for this. Okay, electric flux will be 0. What is the condition? Whatever the flux is, field lines are going inside should be coming out. If it is both are equal, it will be 0. I am talking about the only uniform. I am talking about the uniform field. Write down the next one. Gauss law. Write on the first point. The electric flux which is linked to a closed surface is equals to 1 by epsilon naught times the charge inside the closed surface. So formula is integral E dot ds will be equals to q in by epsilon naught. This is the formula. Integral E dot ds will be equals to q in by epsilon naught. So right, so write down the question. So I have taken a system. So there are charges which is present inside the system and outside the system. Let me consider Q1 minus Q3 plus Q4 and Q2 and Q5 are outside. Okay. So 1, 2, 3, 4, 5 charges are there. inside the system and surrounding the system. Now if I want to find what is the electric flux of the system, so what is the formula? It says that, and what is the sentence says that? Once you read the sentence, electric flux linked to a closed surface is equals to 1 by epsilon naught times the charge inside the. So can I say that flux is equals to Q1 minus Q3 plus Q4 by epsilon naught? This is my answer. That's the flux. Yes, no, like whatever the charges which is present inside the system by epsilon naught. That's the sentence says, no. So from now, no, we'll talk about this Gauss law to find the electric flux. Okay, take down. So when I talk about the charges, obviously the charge will produce the electric field line, no, the imaginary lines. Yesterday evening we have talked about the properties of the charges and the field lines. So we have talked about the imaginary lines, everything, no. So when I talk about positive charge, the field lines will be going outside to the infinity. For negative charge, from infinity to the terminating point inside, right, no. So obviously every charges will produce the field lines, no. Yes or no? Now the question is, write down, if a point charge q, this plus q can take, if a point charge plus q is placed at the center of a cube, then outflux through any one face of the cube, okay. So we know the formula for electric flux, we know the formula for the Gauss law also for the electric flux. What are the formulas? E dot ds, one formula, and for the Gauss law it is like q in by epsilon naught. So if I talk about the cube, so I have placed a point charge here, okay. So this charge will produce electric field lines or not? Yes or no? So how many faces are there for the cube? Through the 6 faces the electric field lines will come out or not? Yes or no? And they are talking about only one face, which is nothing but 1 by 6th, correct or not? Yes or no? Now what is the formula? Integral E dot ds will be equals to q in by epsilon naught, but they are talking about only the one face, which is nothing but q by epsilon naught into 1 by 6, which is equals to q by 6 epsilon naught. If they are talking about the 4 faces, which is nothing but 4q by 6 epsilon naught, which is nothing but 2q by 3 epsilon naught. Getting the point? Out of 6 faces, I am talking about only one faces, right now. Out of 6 face, 4 faces I am talking. If I talk about every face is coming out, so 6 by 6, which is nothing but q by epsilon naught, okay. Take down. Completed. The next question. The flux coming out and entering a closed surface, the closed surface as given in the figure, that figure is given here. Okay, this is the figure. Now find the charge which is enclosed by the closed surface, Okay, in bracket you can write flux. Okay, now give me the answer for this. What is the flux? $35, the number, okay. They are talking about the charge. What is the formula? Phi is equals to Q by epsilon naught, no? Then Q will be equals to phi into epsilon naught, right now? Can I write phi is nothing but E dot ds, phi is nothing but Q in by epsilon naught, or Q by epsilon naught, like the charge and the epsilon naught. Can I equate them? E dot ds will be equals to Q by epsilon naught. What is the thing they are asking? The charge. Q is equals to E dot ds into epsilon naught. What is the given thing there? Question, read the question. The field lines are coming in and going out, they have given. Directly they have given. So coming in, going out, field lines they have given, area also, with respect to area also given. So the total thing is 35. So which is nothing but 35 epsilon naught. That's the answer. 35 epsilon naught. You can take out the page number 162. 162. So we have done some questions based on the Gauss law also. We have done questions based on the flux also. Okay. Now you can mark that application of the Gauss laws. Application of the Gauss laws and continuous charge distribution. So based on the linear charge distribution, areal charge and volume charge. Turn this. Okay. Write down some more applications in your books only near that. Field due to see what are field due to hollow conducting sphere at an outside point. So formula is E is equals to KQ by R square. E is equals to KQ by R square. The next one, field due to non-conducting solid sphere, field due to non-conducting solid sphere at an inside point. So formula is E is equals to KQR by R cube. KQR by R cube. Small r by capital R cube. Next one, field due to non-conducting solid sphere. So first one we have written about the inside point, no? Now it is outside point. Solid sphere at an outside point. Formula is E is equals to KQ by small r square. Okay, done. Now the next heading is properties of conductors regarding charges. Properties of conductor regarding charges. So what it means like based on charge I am talking about the conductor. So what is meaning of conductor? Which allows the flow of electrons, right? Write down the first point. Charges always lies on the surface of the conductor. Charges always lies on the surface of the conductor. So yesterday we are talking about the conductor. So charges we have talked only in the in the adjacent to the walls, no? Yes or no? Like whatever example we have taken yesterday, like 50 people are there in the room, no one likes each other and will go away from each other, right? No, the same thing. So yesterday we have told the thing, but now we will talk about in terms of property. Second one, you can take the diagram for the first one. Second point, if there is a cavity, what is the meaning of cavity? Like there is empty space. Not teeth cavity. If there is a cavity inside, if there is a cavity, CAVITY, if there is a cavity inside, charges will lie on the surface of the conductor, not on the cavity. I will repeat the sentence. If there is a cavity inside, charges will lie on the surface of the conductor, not on the cavity. So if I talk about the same diagram, some cavity presents here, okay, but charges will always lies on the surface of the conductor, not on the cavity, okay. Now next one. You have taken the diagram for the second one. Third point, if there is a charge inside the cavity, if there is a charge inside the cavity, then charges are induced on the surface of the cavity, okay. If I talk about some positive charges there, so positive charge, if it is there, what is the point they have told? Like charges will induced on the cavity. So if charges should be induced on the cavity, what charge should come near to the positive charge? Negative charge, that's it. If positive is there, it will go away, no? Yes or no? If positive is there, it will go away. Like if I take this also positive and this surrounding also positive, it will go away. But the point is, whenever the charge present inside the cavity, charges should induce the surface of the cavity also. Okay, this is the diagram. If I talk about the negative charge inside, positive will be there and the surrounding will be negative, the vice versa. The next point, if a charge is present, if a charge is present, if a charge is present outside a conductor, outside a conductor, outside a conductor, then charges are induced on the surface of a conductor, then charges are induced on the surface of a conductor. So by these 2 points we can understand that induced means nothing but like some charges are there outside also, inside also. Okay, if I talk about this is my conductor, so if I talk plus q is there, okay, plus q is there, what is the thing they have told? Charges are induced on the conductor. What charge should be induced here? Negative. If this side is negative, what charge should be in opposite side? If there is a cavity, there will be any charge induced on the cavity? No. If any charge present inside the cavity only, charges will induced on the cavity. If there is no charge will induced on the cavity. Okay. Okay. This is about the charges, I mean conductor regarding charges. Okay. Now we will talk about a question here. Write down. Consider a neutral conducting, consider a neutral conducting sphere, neutral conducting sphere. A point charge, in bracket you can take positive, a point charge in bracket positive is placed outside the sphere, then the net charge on the sphere is dash. Okay. So based on the properties whatever we have seen now, give answer for this question. It's a simple answer. Zero, correct. But how? Positive, negative, neutral. Words are correct, but frame it in a sentence. Words are correct, like zero you have told, positive charge, negative charge and neutral you have told, but what is the thing I need in a sentence? If you say in sentence, surface paina, okay, listen here, I have taken a positive charge outside a conductor, okay, but the conductor they have, like the body they have told conducting body, it's a neutral. Neutral means what? Equal positive and equal negative. If I take a positive here, a negative charge will induce in this surface, no? If I talk about 5 negative charge are induced, how many positive charge will induced here? 5. Then only it will be a neutral body, no? Whatever it can be, the charge if I take, the body will be neutral or not? Yes or no? Then what is the charge induced inside? 0. That's it. Answer is 0. The question itself saying it's a 0 and they are talking about the answer, and the answer is also a 0. Completed? Now next subheading, properties of conductor regarding field, properties of conductor regarding field. What field we are talking here? Electric field. Okay, the first point we are talking now. What is the first point in the conductor in charge? Charges are induced on the surface of the conductor. Is there any charge present inside the conductor center? Is there any charge present at the center of the conductor? If there is no charge, will there be any field? If charge is there, field will be there, no? Positive charge aina sare, negative charge aina sare. Like if charge is there, field will be there. Whatever charges are there, I have taken in the surface of the wall. Now anything is present in the center? No. If nothing is present, obviously there will be no field produced, no? Yes or no? So the first point is the field inside the conductor is always 0. The field inside the conductor is always 0. So which is nothing but E is equals to 0. So you know the reason also now? Yes or no? Because charges are always induced on the surface of the conductor. It is not present at the center of the conductor. So since there is no charge at the center, there is no field. If charge is there, field will be there. Okay. The next point. The field lines are always perpendicular. The field lines are always perpendicular to the surface of the conductor. To the surface of the conductor, in bracket, irrespective of shape. In bracket you can take irrespective of shape. So what is the meaning of irrespective of shape? It can be any shape, but the field lines will be always perpendicular to the surface of the conductor. Okay. Third one, the next point. The field just outside a conductor is given by sigma by epsilon naught. Sigma by epsilon naught. So it is nothing but E is equals to sigma by epsilon naught. So this is one formula. Okay, sigma by epsilon naught. Full stop. Sigma is inversely proportional to the radius of the curvature. Sigma is inversely proportional to the radius of the curvature. So sigma is nothing but surface density. Surface density. So how I am telling that sigma is inversely proportional to the radius of the curvature means E is equals to K Q by R square. This is the formula, no? If I talk about that formula, which is equals to sigma by epsilon naught. So sigma is inversely proportional to R square, right? It is inversely proportional, no? Yes or no? If there is a question, like let me take a question. One, and this is 2, and this is 3. Okay. So 3 surfaces I have taken, and I am talking about the densities also. Sigma 1, sigma 3 and sigma 2. So arrange them in a descending order. This is the equation. Okay. If this is the equation, what I should see is, no need to calculate anything. See the curvature. See the curvature. If curvature is big, density will be small. If curvature is small, density will be big. Then arrange them. Which one will be greater? Sigma 2 will be greater. Then sigma 3 or 1? 1, then 3. So 2 greater than sigma 1 greater than sigma 3. This is the order. Why we are not taking sigma 3 in front of 1? If I take a circle, if I take a point, if I try to zoom that circle, no, will I get a line? Yes or no? Max people. The next topic is properties of conductor regarding potential. Properties of conductor regarding potential. The properties of conductor regarding potential. First point. The entire solid surface of a conductor is equipotential. So equipotential means, if I talk about this is a conductor, no, this is one point and this other point I am taking. Okay, what is the meaning of equal potential I have told. So potential at point A and potential at point B. So potential can be any number here. Let me take 5. So if I talk about delta V, the potential difference between point A and point B, what is the potential difference? 0, that's it. Since it is a same potential, no. So if I talk about this has 5 and this has 5, so which is nothing but VB minus VA, so 5 minus 5, 0 I will get. So delta V will be 0. The change in potential always 0 at the surface. Done. The next point, the equipotential lines just outside, equipotential line just outside the conductor, just outside the conductor, have the same shape, have the same shape as that inside, as that of inside, have the same shape as that of the inside of the conductor. Same shape as that of the inside of the conductor. Enough. Listen. So if I talk about this is the conductor, okay. So if I talk about the potential, no, it will be having same shape. Like if I draw like infinite potential also, the same shape will be followed, okay. So if I talk about this is V1, this is V2, up to Vn also I can draw the same shapes. Third point, you can take the diagram and we will go for the third point. Third point is when two conductors are connected, when two conductors are connected, when two conductors are connected, two conductors are connected, charges will flow, charges will flow till the potential are same, till the potential are same, till the potential are same, charges will flow till the potential are same. Now we will talk about the thermal properties of matter and thermodynamics. There we have talked about the change in temperature, that is Q by T is equals to K A delta T by L, right? No, there we have related the formula V is equals to IR. Yes or no? The change in potential is nothing but there we have talked about change in temperature. If I talk about a hot water and a cold water, if I mix together, what happens there? It will become normal, which means the temperature will exchange and come to the same potential, like same temperature. The same concept we are using here, okay. Write down the next one. Fourth point, when a conductor is connected to earth, potential is 0, connected to earth, potential is 0. If I talk about this is my conductor, if I take this conductor and if I connect to the earth, no, the potential is 0. Write down next subheading. Rules for charge distribution. Rules for charge distributions. Rules for charge distributions. The first one, charges on opposite charges on opposite phases, charges on opposite phases are in opposite sign, opposite phases are in opposite sign, but same in magnitude, but same in magnitude. Second point, use charge conservation, use charge conservation on conductors or connected bodies, charge conservation on conductors or connected bodies. Third point, presence of charge will induce charges on surface, Okay. Now I will take a simple example here. So there is two conducting bodies. So how many surfaces are there? So this is one surface, second surface, third surface and the fourth surface. Inside, outside, and for this also inside and outside. So let me consider 1, 2, 3, 4. Okay. Now I have taken a charge Q for the surface of the 2. Okay. I have taken charge Q on surface 2. Now I need to distribute the charges now. If I distribute the charges, whatever charges are there in 1, 3, 4, like it is 0, no? At last also I should get the 0. Now how can I distribute it is like based on these rules. So if I talk about the first one, inside nothing is there, no? So can I say the first one is 0? Second one they have given, it is Q. What is the opposite side? It is minus sign should be there, same magnitude should be there. So it will be minus Q. Opposite side, no? When I talk about the fourth one, it is opposite, no? The same body. So it is plus Q. Can I add everything now? If I add everything, will I get the Q charge? Yes or no? Will I get the Q charge? I will take one more example. Two bodies are there. This is Q and this is 2Q. Okay. Now I will talk about the conservation of charge. So conservation means I will club together. How many charges are there? Clubbing together. 3 charges are there. How many surfaces are there? 1, 2, 3, 4. How many bodies are there? 2 bodies, 4 surface, 2 charges. Okay. 2, like club chase 3Q will come. Like charges I am talking. 2 charges are there, no? Q and 2Q. So Q plus 2Q, 2 bodies are there. So divide by 2, which is nothing but 3Q by 2. So how to distribute means I will take this is 3Q by 2 and this also 3Q by 2. Now what is the charge here? Q charge. So Q minus 3Q by 2. How much I will get? Minus Q by 2. What about this one? Opposite side. This one will be plus Q by 2. If I club together, what is the charge now? 0. 0. 0. How yes? 3Q by 2 plus 3Q by 2 will become 6Q by 2, which is nothing but, so total charge is 3Q. I should get 3Q as the answer. 3Q charges are there, only 3Q should be there. I should distribute the charges. Okay. If I consider 3 bodies, let me take Q, 2Q, 3Q, or let me take this as 3Q and 5Q. So how many charges are there? 3 charges are there, 3 bodies are there. So add the charges, divide by body, take the charges to the end of the bodies. Then Q minus this charge and opposite side, again I will do it. Okay. Opposite side I will get, again 3Q minus that charge whatever I am getting here. I will keep it here, again I will go for the opposite side. So club together I should get the same charge. So this is your homework now. That is okay. I will give time now. You can take your time and do and tell that answer. I will explain once again this one. When they are giving plates, 2 plates are there, 2 charges are there. So club the charges, divide by how many plates are there, and take that charge, whatever charge I am getting, the net charge, take that to the end of the plates, end of the 2 plates. So what is the first plate having? Q. So Q minus 3Q by 2. I will get minus Q by 2. That is for the opposite side of the plate. Okay. Now what is the opposite side of this one? 2Q is there. So this is minus Q by 2 means this one will be plus Q by 2. That's it. Already I am having this 3Q by 2. So if I club together, will I get 3Q? 3Q by 2 plus 3Q by 2, which is nothing but 6Q by 2, which is nothing but 3Q. So similarly I need to do for this one. Do it.